Welcome back. As you know, I'm Eli the Computer Guy, and in today's class, we're going to be talking about DHCP, Dynamic Host Configuration Protocol. This is a protocol that is just absolutely amazing. It's one of those things in the technology world, it's almost like water. You know, it's just so ubiquitous, it is so everywhere that nobody really thinks about it a lot until it's not functioning properly. And of course, you being a technology professional, it's your responsibility to understand what to do if it's not working properly. When we talk about DHCP, this is a protocol that allows client computers to connect to a DHCP server and be able to automatically get IPv4 address information, right? So you should be used to using this service at this point in time. Basically, you walk into an internet cafe or you plug your computer into the network and your computer automatically is able to get a usable IP address, a subnet mask, a default gateway, a primary and secondary DNS server, and that all happens through the DHCP process. This is really great because back in the old days, before we had DHCP, everything had to be a static IP address. What we mean by a static IP address is that this is a hard-coded IP address that you would have to manually go in and configure for every computer, server, networking device, the whole nine yards, and you would have to plug in an IP address and a subnet mask and a default gateway, the DNS servers, the whole nine yards, and you had to make sure that you did not copy the same configuration for multiple computers on the network. Crap, okay, I'm gonna make this server 192.168.1.2. But darn, is somebody else using 192.168.1.2? And crap, some noob turned off ICMP so I can't ping anything on the network because that's what noobs do every once in a while. Right? And then you could get into problems when you had to hard code, you had to manually input the static information. You could get duplicate addresses. It was very easy to fat finger things so that you didn't put in the right configuration. And it was just a complete and utter pain in the ass because if you have, 5, 10, 100 computers that you have to manually configure with their IPv4 information, that just kind of sucks. Do remember, as a technology professional, one of the things that we try to do is we try to automate and centralize everything, right? If you have to sit down at an individual computer to do configurations, that's just going to make your life miserable. That's why we use things like DHCP to dynamically give IP addresses. That's why we use Active Directory in the Microsoft world in order to centrally manage and administer all of our systems. And so what DHCP does is it allows us to have one place where we can manage our IP address scheme, be able to automatically give out the IP address information to all of our clients, and that's what we're going to be talking about today. Now, one of the first things that you have to remember whenever you're using any kind of client-server architecture, when we talk about a client-server architecture, that means you have client computers that communicate with servers in order to be able to get information or do something, right? One of the big things to remember in a client-server architecture is you actually have to configure the client to be able to communicate with the server that it's trying to communicate with, right? In the DHCP world, this is relatively simple. But if you don't know what you're doing, or if, again, one of those little interns that you just hired decided to do something stupid, you could run into problems. Over here I have on the screen, this is the network configuration panel for a Windows computer. It'll be a lot the same regardless of the operating system you're using. If you're using Mac, it'll look a lot like this. If you're using Linux, if you're using GUI Linux, it'll look a lot like this. If you're using command line Linux, well, you're so smart, I'll let you deal with that, right? But one of the big things that you have to remember is to actually configure the internet configuration on your computer, the network configuration, to actually use DHCP. So you will see something like in the Windows world, it says obtain an IP address automatically. That is what you are going to want to have checked off in order to use DHCP. If somebody has configured to use the following IP address and they have IP address information already configured within this network configuration panel, that will be the IP address information that your computer is using. So you can run into problems with this a lot of times. Let's say you have remote workers, especially in the modern world, remote workers, sales staff, that type of thing. Sometimes, for whatever reason, when they go to a particular site, they may need to manually put in some IP address information for their computer to work properly at that site. And then, of course, being users, they forget what they did. And so then they come into your site, they're not able to connect to the network, and they're like, the network is down. And it's like, no, you just need to go back and check the whole thing, obtain a IP address automatically. So that's one thing to remember in the troubleshooting world. The other thing to remember in the troubleshooting world is our DNS configurations down here. So we had a whole class on DNS before, and DNS can run you into a lot of problems, especially with DHCP, because one of the things with the DNS information is you can actually configure your DNS on your local computer to use manual DNS addresses instead of using what comes down from the DHCP server, right? So the DHCP server is going to give you your IP address, it's going to give you your subnet mask, and it's going to give you your default gateway. You do have the option to basically manually put in your own DNS server information and basically override whatever the DHCP server would give you. You can run into a lot of problems with that because many times, especially salespeople, right? Especially salespeople, folks that think they know what they're doing with their computer, they'll manually override those DNS settings in order to connect to Google's DNS servers or Cloudflare's DNS servers, those public DNS servers, so that their system is faster and they have more anonymity when they go to porn sites or whatever else. Because you know that's what they're doing with their company laptops. Remember, when you get a company laptop back in after a salesperson quits the company, have a lot of Purell and spray that thing down. It's just true, right? Anyways, one of the big problems you can have, though, is if they configure the DNS server here manually, remember, those public DNS servers do not know what's going on inside your internal network, right? So the computer then, what's going to happen, their computer is going to go out to the cloud, to the DNS servers out in the cloud, and they're going to ask the DNS servers out in the cloud, hey, what is the IP address for server, right? So you have an Active Directory server, a file server, something that is in your own internal network, and the DNS out in the public cloud is going to have no idea because that's not their problem. They resolve to CNN.com or Dropbox.com or something like that. They're not going to resolve the internal server IP address. And so this is one of the things that you can get screwed up from a troubleshooting standpoint is again, people that are, they're smart enough to open up the network configuration panel without fully grasping what the hell they're doing. But anyways, as long as you have obtain the IP address and as long as you have obtain the DNS address, basically what's going to happen is when your computer connects to the network, so you may have a switch, basically you're going to connect to the hardwired network, the Cat5 network, or you're going to have a wireless access point, and so you're going to connect with wirelessly. Basically on this network, you're going to have a DHCP server, right? So this DHCP server is going to have a whole bunch of information about what it's allowed to provide to the clients. It'll have what's called a scope. We're going to talk about this in a second. We're going to talk about lease length, something called lease length. We'll talk about in a second. Reservations and a few other things, right? So basically the DHCP server is going to have some basic configurations in it to be able to send the IP address information to the client. You're going to have your computer connected either hardwire or wirelessly. It's going to say, hey, I need an IP address. It's going to communicate on the network. Again, remember, DHCP is a protocol. A protocol is a language. Different languages do different things. This language is basically for a way that the computers can very easily communicate with the DHCP server and bring down that IP address information. So it's going to communicate with the protocol. It's going to find the DHCP server. The DHCP server is then going to give the client the IP address information that it needs, and away you go. So it's a pretty easy thing. One of the things to remember, though, a very important thing, is that basically you can only have one DHCP server per LAN. So this can be a big problem when people just start plugging things in willy-nilly on a network, as people do, is remember, because of how this protocol works, you're going to have your computer plugs into the network, and then it's going to communicate out, and essentially it's going to go to the first DHCP server it can resolve to and get an IP address that way. You can run into a problem because if you put multiple DHCP servers on your network, they do not necessarily talk to each other. They don't necessarily know the other one exists, and so then one client can be getting DHCP information from one DHCP server, another client can be getting information from a different DHCP server, and everything can go to hell. You can have basically computers on the network with the same IP address. So you have two computers with the IP address of 192.168.1.10. Or one of the bigger problems, right, is let's say you have your network, right? You have your network and you have sales guy. And sales guy is so smart, right? Sales guy, was given participation, ribbons back when he was 2 years old. He was winning his participation ribbons. He went to school and he always got, the gold stars and all that. So he knows that he is smart. Little halo effect for the salesperson world. And one of the issues is that when he goes into the office, he doesn't get the Wi-Fi signal that he wants, right? For whatever reason, again, this can be a real problem, right? The CEO has decided they're not going to upgrade the Wi-Fi infrastructure, and so the salesperson is a little sad because they're not getting the Wi-Fi signal that they want. Well, so you have this network, and you have the Wi-Fi access point. So a Wi-Fi access point is only an access point. It doesn't have DHCP, it doesn't have DNS, it doesn't do anything else. All it does is allow people to connect wirelessly. And so smart salesperson says, well, I want Wi-Fi in my office, and I have this Wi-Fi router at home. So what I'm going to do is I'm going to bring my own Wi-Fi router in. I'm going to plug it into my office so that I can get my Wi-Fi signal. Yay! Right? And that smart, wonderful salesperson that's been getting participation ribbon since he was 2 years old now has fixed his problem. The issue is a salesperson knows a little bit, but only a little bit. So once they connected this Wi-Fi router to the network, the issue then becomes is not only are they getting the Wi-Fi signal, but depending on how they plugged it into the network, the Wi-Fi router may actually be advertising itself as a DHCP server to the rest of the network. Now you have your DHCP server over here, and all of a sudden you're getting weird networking problems because let's say the DHCP server is supposed to be 192.168.1.x. Basically, that's the network that your DHCP server is presenting. And since a salesperson doesn't know anything about DHCP servers and subnet masking and all that kind of stuff, his DHCP server that he brought in is advertising the 10.1.10.x subnet. So basically, every computer on the network, whenever they connect to the network, they're going to say, hey, I need a DHCP address. Whichever DHCP server resolves the IP address first is the IP address the client is going to take. And so all of a sudden, you start having a whole bunch of computers with this frickin' stupid ass subnet mask, and now they're on an entirely different subnet mask. And remember, subnet mask, that network, through IP address schemes, they cannot communicate with computers on different subnets, and then just everything starts going to hell. Because guess what? Smart sales guy isn't nearly as smart as they think they are. And that can be a fun thing. So one thing to keep in mind. The other thing to keep in mind is I don't know if Microsoft still has this problem. Microsoft had a real problem back in the day with their DHCP server. So you would have your Active Directory server, your DNS server, your DHCP server, all on one Windows server. And one of the weird things that would happen, and again, I actually got paid money for this. This is something I actually made quite a few thousands of dollars over the years, is you go into a business environment, and again, that little salesperson, being the smart, happy person that they are, they would install their little wireless router with DHCP. And one of the weird things with Microsoft servers back in the day is that when the Microsoft DHCP server recognized another DHCP server on the network, it would simply turn itself off. Literally, there wasn't even competition between DHCP servers. There was something about how, and again, this was 2008 timeframe. Hopefully, they fixed this problem. There was something about Microsoft with their Windows Server. If you had DHCP server services installed on your Windows Server and it detected another DHCP server on the network, it would just shut the DHCP service off, and then everything got brutal really quick. So a big thing to understand here is that you will only have one DHCP server per LAN. Now, again, if you're dealing with the Microsoft world, if you're dealing with the enterprise world, there's always like one of these, this is how it is, except in the few times that it isn't. One of the things in the Microsoft world is sometimes you'll have clusters or you'll have failover. So you may have one DHCP server on a Windows server, and then you may have a failover DHCP server on a Windows server. So essentially you have your primary DHCP server and your secondary DHCP server. This is configured within the Windows server environment, and basically the idea being here is you have this backup DHCP server. If the first DHCP server fails or cannot be communicated with for a while, then the secondary DHCP server, that one goes online so that users can get access to it, and then the maintenance people can figure out the problem. This is something kind of specific to the Windows world or that larger server enterprise world. So in general, if you're dealing with offices with 500 or less users, most likely, you're just going to have one DHCP server per LAN. Just realize if you have more than one DHCP server, it's more of like a DHCP service where you do a whole bunch of configurations to make sure things don't go poorly. So now let's talk about the configurations that you can actually do on your DHCP server. Now all the basic configurations are the basic configurations regardless what DHCP server you're dealing with. If you have a Microsoft DHCP server, you're going to be able to say what the scope is, you're going to have the reserved addresses, you're going to have the DHCP lease length. This is going to be the basic information that you can put into a Windows DHCP server. It's also the same basic information you can put into that crappy little Wi-Fi router that you have in your house. The Wi-Fi router that you have in your house, again, is also a DHCP server. It's also a DNS server, the whole 9 yards. And so this is a basic configuration that you would put into that too. Now, again, when you get into the enterprise world, there might be some higher level configurations, but this is the basic stuff that you need to know to get your DHCP server off the ground. So the first thing that you need to think about is what is called the scope. Essentially, you are going to create address pools. So most of the time you'll just have one address pool, but what this is what are the addresses that are available for your DHCP server to be able to assign to DHCP clients. So if we look at the 192.168.1.x network, right? So this would have a 255.255.255.0 subnet. Right here, basically we have up to 254 addresses that we can put into a pool. That's part of the scope that can be assigned to clients that connect and need a DHCP address. Again, do remember when we're talking about actual usable network numbers is the lowest number in an IP address range. That is considered the network ID, and the highest number, so 255, is the broadcast number. So if somebody needs to communicate to all the computers on the LAN, they would use the highest number. And so what is left is you get IP addresses 1 to 254. So 192.168.1.1, 192.168.1, all the way up to 254, and these are all the addresses within this particular subnet mask for this particular network. So theoretically, within your scope, you could put 1 through 254. But the problem is, that's all. That's all of the addresses within that particular network. And you're going to have your router, and that's going to need an IP address, 192.168.1.1 most likely, right? That's the default gateway. You're probably going to have a server of some sort, let's say 192.168.1.2, and you're going to have, 3.3.4.5. You're going to have print servers, you're going to have wireless access points, you're going to have other addresses. addresses, where basically you need to have a static IP address for those particular devices so that you can interact with them, maintain them in the whole 9 yards. So you would almost never use a scope of 1 through 254, because the issue is if you tell the DHCP server that it is able to assign 192.168.1.1, it will then assign that number, that IP address, to another computer on the network. You then have two computers on the network with the exact same IP address, and everything goes to hell. It is important to understand that generally assume DHCP servers are stupid. Assume they're stupid, and then if you have some high quality piece of software, then go from there. So DHCP servers do not scan the network. They do not go out and proactively try to figure out what's on the network to determine what IP addresses that they can or cannot give out. Essentially, all they have is they have some records inside some little database table that states whether a current address has already been checked out of the DHCP server and how long the lease length on that is. So essentially, just realize this with the DHCP server, it's not pinging. So if a client wants an IP address and the DHCP server says, okay, this IP address is available based off of the information within its records, it will not proactively ping or try to do any kind of network discovery to try to determine if a device with that IP address is already on the network. It'll just give that IP address. Then you have two computers with the exact same IP address. Depending on what the computers are doing, that can be better or worse. If it's, 192.168.1.100, so just kind of, crappy client computers that are on the network, they'll probably just have some weird, quirky problems. If, on the other hand, to be clear, if you have two computers or more on the network with the same IP address as the default gateway, right? The default gateway is the computer or device all the computers on the network go to if they can't resolve an IP address or domain name on the local network, right? So basically, when you try to get out to the internet, when you try to get out to the wide area network, you're going to go through that default gateway. If you have multiple computers on your network with the same IP address as the default gateway, you are just going to have a tremendous number of problems. So when you're sitting there and you're thinking about your DHCP scope, you do not do 1 through 254 or basically all the IP addresses that are available. Essentially, what most people do is they look at how many computers they think that are going to be on the network, right? So if you have a small business network, maybe you have 10 or 20 devices on the network. If you have a larger network, you may have 500 devices. And so, it's kind of like one of those rule of thumb things. So, I'm just gonna put more addresses in the scope than I know that I need, right? So if I know I have 10 computers on the network, plus more devices may connect to the network, smartphones, printers, that type of thing, I might just say, okay, you know what I'm gonna do is I'm going to create a scope, and I'm gonna make that scope 192.168.1.50 to 192.168.1.100, right? So basically what that does is that gives me 50 IP addresses within the scope that are able to be given to clients. I think I will only need 10, so this gives me more than enough. Do not cut it close. Do not try to cut it close and be smart. 192.168. Let's say 1.50 to 0.60, right? Hey, I only have 10 devices on the network. I'm only going to give myself a scope of 10. Let me be clear. These IP addresses don't cost you any money. It's not that these IP addresses don't cost you a fraction or only cost you a fraction of a cent. They don't cost you any money at all. So giving yourself a wide range is just better for everybody involved. If you cut it close like this, you may run into problems where Oh, the DHCP server thinks it thinks that it's already assigned an IP address to a computer, but that computer doesn't realize that it thinks that it's supposed to have an IP address, so it asks for another IP address, and so then the DHCP server can actually think that needs more IP addresses than it actually needs, and you can run into some problems. So basically, all the scope is basically all the IP addresses that are available to provision for DHCP servers. Now, when you're dealing with Microsoft World, again, the Microsoft World, you start dealing with larger server infrastructure. You will also see the concept of pools. So pools are basically where you can have multiple essentially scopes, right? So I might say I want 192.168.1.50 to 100, and then for some reason I may also say 192.168.1.150 to 200. Right? I don't know. For some reason, I might do something stupid like this. Again, do remember, in the technology world, it literally is as much art as it is science. There's the technical way of doing things, and then there's why you do it. Sometimes you can get some weird things. Let's say you have legacy networking equipment, right? For some reason, one networking person back in the day, they used the low numbers of your IP address, your subnet mask. So let's say they used .1 through .20 for whatever reason. So you need to make sure that those addresses aren't provisioned in your scope. But then you had somebody else, and they decided to do something different, and so they decided to use, I don't know, .120 to .130 for different networking equipment for whatever reason. And so you may have these chunks within the middle of your subnet that can't be used, and that's why you might create pools, and then those pools then go into the overall scope. Most likely you're not going to have to do this. This is something you will probably have to remember for a Microsoft test if you ever do it. I'm just kind of telling it here just in case you need to know. Then, basically, again, within the Microsoft world, and then within some of the DHCP server software you might install on Linux or something, you will have the option for configuring reserved addresses. So basically, what the reserved addresses do is this is more or less like a notebook for the administrators to know why certain addresses were set aside, right? So you may have a reserved address, and it'll be like 192.168.1.1, and that will correspond to your router. Then you have 192.168.1.10, and that will correspond to your Active Directory server. So within the DHCP server software, you can assign the IP address to the type of equipment that it's supposed to be connected to. Now, it is important to understand you actually have to go into these devices or pieces of networking equipment and actually configure the static IP address for these devices manually. What the reserved address system is used for is basically so when a new administrator sits down and they're looking at your DHCP infrastructure, you're looking at the overall infrastructure, they can say, oh, okay, so 192.168.1.1 is supposed to be the router. Now let me go and see if the router is actually there. Okay, 192.168.1.10, that's supposed to be the Active Directory server. Oh, let's make sure it's actually there. And you go through, .12 is your Exchange server, .13 is something else, so on and so forth. Basically, this is a way to essentially kind of document what's going on with your network. The important thing to understand is all of these computers or networking devices will have to have their IP address information entered onto them statically, though. So don't just assume because you configured the reserved address within the DHCP server that's somehow going to automatically configure these particular devices, kind of just like a notebook. Then the final thing to look at when you're dealing with the basic DHCP server configuration is lease length. Right? And so basically what this is when the DHCP server provides an IP address to the client, it's more or less a time to live on that IP address, right? How long should the DHCP server wait before it assumes that that computer is no longer on the network and the IP address that was assigned is now available to be assigned again? What essentially happens here is you configure the lease length within the DHCP server. It can be 1 hour, it can be 1 week, it can be 1 month, right? DHCP server really doesn't care. What happens, right, is you have the client that connects to the network. It'll initially contact the DHCP server and say, I need an IP address. The DHCP server will then give an IP address, 192.168.1.10, let's say. And then it will give a lease length. So it'll say, you have this lease, let's say, for 24 hours. What is supposed to happen is after 12 hours, so basically, whatever the lease length is divided by 2, so for this it would be 12 hours. At the 12-hour time frame, the client computer is supposed to communicate with the DHCP server and say, hey, I'm still using this IP address, I just want you to know. As long as the server responds, you reset the lease length all the way up to its maximum length, and the computer keeps going along. What happens with this, though, is again with computers and network communication, it doesn't always work properly. So after 12 hours, your client computer is going to communicate with the DHCP server. If that does not occur for some reason, then it will keep the lease length as it currently is. Once that lease length is then half as much as it currently is, so it goes from 24 to 12 to 6 hours. At the 6-hour mark, then the computer will try to communicate with the DHCP server again. If the DHCP server responds, the lease length gets reverted back to the 24 hours. If it doesn't respond, then it waits till it gets to the 3-hour mark, then tries to communicate with the server, so on and so forth. And basically, once it gets to the end, or whatever the predetermined thing within the configuration, basically the IP address is considered not available anymore. The DHCP server then puts it back into its address pool, and away you go. So the lease length here is a very important thing, because basically this is one of the things that tells the DHCP server what addresses are currently available. Okay, I gave this one out for 24 hours. I give this one out for 24 hours. I give this one out for 24 hours. I give this one out for 24 hours. If it doesn't hear back from the clients within the appropriate period of time, then that IP address is put back into the pool so that it can be given out to another client. Now it becomes interesting, again, when we talk about, the technology world, it is both science and art. All technology is quirky. All technology is quirky. Even DHCP can be quirky. Even in the 2020s, DHCP can be quirky. And so one of the things that you have to think about for lease length is basically how often do you think computers are going to change on your network, right? So let's say you have an old school office. Let's just say you have an old school office. Everybody has desktop computers. Everybody has those desktop computers, and they are hardwired into the network. And so basically those desktop computers only get unplugged from the network essentially when they die, when you have to swap the hard drive or something like that. If you're dealing with that environment, then you probably want a long lease time, because, again, remember the DHCP client has to communicate with the DHCP server. If something fails there, it can cause problems on the network. And so the longer the lease length is, the less amount of time your clients are going to have to communicate with the DHCP server, less likely that something is going to get screwed up. So you may want to have a lease length on, an infrastructure where it's all desktop computers, where computers come in very unoften. You may want that to be something like 7 days. I would just say like 1 week. You don't expect the computers to get switched out very often, so that should be fine. You decrease the amount of times the DHCP clients have to communicate with the server, and so you should be good to go. On the other hand, let's say you have a cafe, right? So you have a cafe, you've got the Wi-Fi signal in a cafe, and you have people that are coming in and out all day long, and they're using your your cafe's internet connection to connect to the internet and do whatever they're doing, right? So in a day, you may have 300 people or more that come into your environment to connect to the internet. Again, if you have, let's say, 192.168.1.x network, that will give you a total number of IP addresses of 254. Let's say you reserve 10 of those IP addresses, .1 through .10, just for your own internal networking infrastructure. That will give you 244 IP addresses usable, and you have 300 people coming into your environment every day that will need to pull an IP address. If this is what's going on, you may just want to take your DHCP lease down to 1 hour, right? Because basically what's going to happen is you have people come in, they're going to connect to your network, they're going to get the, whatever it is that they're getting, they're going to walk out the door, and so their computer, their little device that's pulling an IP address will not try to communicate with the DHCP server after that hour time period is gone, and so the DHCP server will re-put their IP address back into the pool so they can get it out to the next person, 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 right? And so that's one of the things to be thinking about with these lease lengths is basically how often do you essentially expect the computers to come into and out of the network. An old school desktop, everybody's hardwired connected into the network. Probably put it up to 7 days. It'll make your life easier, fewer glitches. On the other hand, if you have something like a Wi-Fi cafe, you may reduce the lease length just so you can make sure that you flush all of the DHCP addresses through your DHCP server on a regular amount of time so that you don't run out of DHCP addresses. So that's the basics of a DHCP server, right? You have your scope, you have your reserved addresses, and you have your lease length. One of the things to remember, though, whenever you're dealing with the infrastructure world is you have different services that interact with each other, and you need to make sure that everybody is communicating with everybody else so that things don't go to hell. This becomes very relevant with DHCP when you're dealing with DNS, right? Domain Name System. This resolves fully qualified domain names, generally host names, for the computers in your network to IP addresses. Well, one of the problems that you can have is, new techies that are trying to reinvent the wheel. One of the things that they'll do sometimes is they'll decide, hey, I want to separate my DNS server from my DHCP server, right? So let's say they find some cool new DHCP server software or some cool new DNS server software. And so they say, I want to put these on 2 different boxes. Here's one of the issues that you can run into, right? So if you have one box that has your DNS and your DHCP, right? When you have your client computer communicate with that box in order to get that IP address, 192.168.1.11, let's say, one of the things that's going to happen in this resolution process is that computer is also going to give the server its host name. Hi, I'm PC1. And so when the DHCP server gives the IP address to PC1, DNS is going to create a record that says PC1 is 192.168.1.11, right? And so that will be in the DNS record. So when you have a different computer on the network that is looking, it's trying to figure out who PC1 is, it will communicate with the DNS server. The DNS will have the IP address record for PC1. And then it will say you need to go to 192.168.1.11, right? So all of this, when it's on one box and the services are communicating with each other properly, works wonderfully. Now, when you're a noob, and you're like, ooh, I'm going to build my own. Why have every server service on one box? I'm going to radically silo or separate off all of my different services. So DHCP will be on one box and DNS will be on one box. and everything else, right? One of the problems that you can have is that you need to make sure that these server services are able to communicate with each other, or that it doesn't matter if the computers that are resolving or that are getting the DHCP addresses, that it doesn't matter if their host names can resolve. Because in this system, right, the computer communicates up with the DHCP server. The DHCP server gives the IP address, and the DNS server is in the dark. It's not given any of that information. So when PC2 over here tries to resolve the IP address information for PC1, it's going to go to the DNS server that is separated now from the DHCP server, say, hey, who is PC1? And the DNS server is going to go, I don't know. Why are you asking me? Why are you asking me? I don't know. And again, then things can go poorly. So this is just one of those things just to keep in your mind when you're thinking about separating off server services and all that. Think about how these server services communicate with each other, and then decide, does it really make sense to put your DNS and your DHCP server on different boxes? You can have a problem with this, like right now. Like, I love pie holes. I love pie holes, and I cannot lie. If you have not set up a pie hole, you need to set up a pie hole. Anyways, what a pie hole does is it actually acts as a DNS server for your local area network. But when you try to resolve to nefarious domain names or advertisers' domain names, it'll basically just sync the DNS resolution, right? So if you're trying to go to a bad site, when you go to the DNS server will see, oh, that's bad site. And so it'll just resolve to like 0.0.0.0, a crap IP address. Then when your computer tries to go to that crap IP address, it will fail out, right? Because it's a bad thing. Well, that's one of the things to consider with a pie hole. This is a very good service. Definitely put a pie hole on your network. But you can configure your pie hole to be a DNS server, and you can have it not be the DHCP, so you can leave the DHCP service running on your router that you have. So you have your router that's connected to your internet. And so one of the issues here is that if you start using that pie hole for DNS services, but your DHCP services are on your router, then if you try to resolve host names internally, server, file server, printer, whatever the hell your host names are, then you can run into problems. So like even with the pie hole, you can configure it. It'll do the DNS services because that's what it's supposed to do. But you can also have the pie hole do your DHCP services also. And so that is one of the things that you would configure. So generally, when you're thinking about it, have your DNS and your DHCP server be on the same box, the same instance, whatever, the same operating system essentially, so that they communicate with each other. And if you're having host name IP address resolution problems, the reason for this is most likely the DNS and your DHCP server services are not communicating properly. Now, along the lines with the DNS and the DHCP being on the same box, I do also need to take a second and talk about Active Directory in the Microsoft world. So if you deal with an enterprise environment, you are going to be dealing with Active Directory. So Active Directory, these are essentially security services for your network that gives you one centralized place in order to administer security privileges, security permissions for your users, for your computers. You can do all kinds of fancy stuff from one central location in order to configure all the security policies for, 10 or hundreds or thousands or hundreds of thousands of different computers. It's a great thing. But do remember, in the Microsoft world, everything kind of gets wrapped up together, right? So in order to make sure your Active Directory network remains secure, Microsoft really wants you to use Microsoft DNS services and Microsoft DHCP service and Microsoft Active Directory services so that they can all communicate with each other properly, and so that information can be relayed and users and computers can get the access that they should be getting. One of the things that I've seen in the past, stupid noob techs, Stupid noob techs do the stupidest things. Sometimes, people will think, hey, maybe I should make my DHCP server or my DNS server. I'm going to use a different server software than what Microsoft provides. So when you purchase Microsoft Server, I think it's Microsoft Server 2019 right now. There's roles, call it roles on it. But anyways, there's services that you can install onto that server. One of them will be a DNS and DHCP and Active Directory. Also things like routing and remote access. These are VPN services, right? And they all really want to be able to communicate with each other and know what the hell's going on. So if you're somebody, I'm not saying who, and you decide to put your DHCP or DNS or whatever on an entirely different box. You decide to do a pie hole in a Microsoft environment. Just realize you're probably going to be a sad person. You're probably going to be a sad person. Because the issue is going to be you have to make sure that your DNS and DHCP is communicating with Active Directory, that Active Directory is communicating with DNS and DHCP, that all of this is communicating with all the other services as they should be communicating, because if all of that communication isn't working properly, then the services will generally fail. So, I don't know. The TLDR is if you're using Microsoft for your environment, just use the entire Microsoft stack. If you decide to use other server services, again, Linux server, Pi-hole, whatever else, you may run into some very weird problems, very weird problems that are just not worth the time and effort. So just use Microsoft. So the final thing to talk about when we're talking about DHCP servers is the very limited amount of security that they offer. Do realize whenever you're building out your infrastructure, whenever you're building out your network, different services on your network have more or less security. And basically for the services that have very little security, you need to protect them with other services that have more security, right? When you deal with DHCP, basically, there is incredibly little security here. Essentially, you connect your computer to the network. It needs a DHCP IP address, and your DHCP server is simply going to give it to it, right? That's just how it works. Again, when you start getting into Active Directory and some other things, you have some security policies there. But by and large, you connect a computer to the network, and it will simply get an IP address from the DHCP server. This is one of the issues with hackers if they're able to get into a facility and connect their Raspberry Pi to their infrastructure somehow. Basically, they walk into an office, they see an unused networking port, and they plug their Raspberry Pi into that networking port. One of the issues is that DHCP server will readily just give them an IP address, 192.168.1.50, let's say, and then the hacker that's using that Raspberry Pi then can use Nmap, to do network scanning, or can then do something else in order to start trying to compromise the devices or the system on the network. This is a real problem. That's why when you're dealing with security, we have multiple levels of security. And so this is one of the reasons that if you have network connections on the walls of your offices, only the ones that are currently active should be connected from the patch panel to the switch, right? That's a form of security. If a hacker comes into your office, plugs into a network port that's dead, right? A layer 1 issue in the OSI model because it's not connected to the switch, then they're not able to scan your network. They're not able to grab an IP address, and they're not able to scan your network. And so something to realize with DHCP is that there's just not a lot of security with it. One of the things that may be part of your DHCP server is you can do MAC address filtering in many DHCP servers. MAC address filtering, again, the media access control address. This is layer 2 of the OSI model. This is literally a globally unique IP address. You know how people are like, oh my golly, Eli, have you heard? The shadow government or whatever, the lizard people, they're going to try to hard code an identifier into every single computer in the world so that it has a unique ID. Can you believe they're trying to do that, Eli? And it's like, you mean what they did 50 years ago? You mean what's actually part of the Ethernet standard as it was created in 1973? Yeah, every networking device in the world has a globally, when I say globally, I mean planet Earth globally, unique identifier. It's kind of how Ethernet works. But anyways, you have a MAC address onto every single NIC, every single network interface card or network port essentially that the device would have. The MAC address, the first part of the MAC address is essentially the vendor ID. The second part of the MAC address is essentially a serial number for that particular network card. And so what you can do with DHCP is you can actually do MAC address filtering. So you can say only provide DHCP IP addresses to computers that have these specific MAC addresses. So that's one of the things that you can do in an environment that you want to be, let's just say semi-secure. Let's just say it's like semi-secure, but you have lots of people coming in and out. So again, let's say you have a wireless network where you're going to have a lot of salespeople, but they're all your salespeople. This is not an internet cafe. You're not going to have guests on the network. You simply have salespeople that kind of rotate in and out of the office all the time. One of the things you can do is as they come into the office, you can grab their MAC address. You can then put that into the DHCP server and say, okay, resolve a given IP address to somebody with this particular MAC address. And so you could have a MAC address filter where you have 200 or 300 MAC addresses within your DHCP server that says if a client asks you for an IP address and it has this MAC address, then provide an IP address to them. That is one way you can try to secure your DHCP server and your infrastructure, and it's definitely something that you should take a look at if you have, again, like that semi-secure environment. Again, within this modern world of like remote workers where you have workers and they do come into the office, so they're going to be on your internal infrastructure, but they're also going to be going home, but they're going to be using the company-owned computer to connect to things. Then that's the type of thing where you might use a MAC address filter just as kind of that additional layer to make sure that somebody can't come in with a Raspberry Pi, just connect to your Wi-Fi, grab an IP address, and start trying to hack your systems. So there you go. That's the basics of Dynamic Host Configuration Protocol, DHCP, right? This is a client-server architecture. A client comes on the network and says, hey, I need an IP address. And more or less, the DHCP server gives it to them. Again, this is one of those things that's so simple, it's so easy that when you have a problem, a lot of new techs will lose their damn minds because a lot of times they don't think about the DHCP server. I've seen this where I've gone in, I've configured my DHCP server settings, right? This is the scope, these are the DNS servers, these are the default gateway. One of the important things to realize, right? If you fat finger something, if you're supposed to put 192.168.1.1 as the default gateway within the DHCP configurations, and you put .1.11 by mistake, now every single client that grabs an IP address from your DHCP server is now going to try to route through whatever poor computer is .11 instead of .1. I've done that, right? The biggest problem with DHCP is essentially when you're configuring the server is literally look at the DHCP panel and then just verify it once, verify it twice, verify it 5 times, and then hit OK. The biggest problems I've had with DHCP are the problems that I've created, to be quite honest with you. Beyond that, one of the big problems that I've seen in the real world, especially with salespeople, and again, this is lived experience for me. This is lived experience. Oh my God, salespeople, if you have not dealt with salespeople in the enterprise world, it's just this weird thing. You talk about, these are people that are not necessarily the sharpest butter knife in the drawer, but because of what they do, they're told they're so special and smart all the time. And so they can make your life a living hell because they do. They bring the company a lot of money, right? They sell stuff. When stuff gets sold, that's what keeps the company going. They're also told how wonderful and special and amazing they are. And so you get people that aren't exactly very sharp butter knives who are also told they're amazing, who also bring the company a lot of money. Oh, It's just painful sometimes. And one of the things that you'll see that the salespeople and those types of folks will do is they'll go into their network configurations and they will screw around with their network configurations because whatever it is that they're trying to do, right? They're trying to bypass some kind of security regime, right? You set up some kind of security regime within your infrastructure to make sure that nobody's looking at porn or doing anything stupid, downloading stuff off of LimeWire or whatever, right? You do that, and then your salespeople walk into your infrastructure and start futzing with configurations to literally try to get around the security policies that you've created. And once they do, they then break things by screwing around with the DNS settings or whatever else, and it can be a bit of a disaster. I've seen this again with like network configurations. They'll screw with the DNS servers in order to try to get around whatever DNS security you have. Proxy servers, so proxy servers, we'll talk about that in another class, is essentially you can go through one server to bounce out through the internet, kind of like a VPN, but without a lot of the security built into it. And so a lot of salespeople, again, I'll beat up on the salespeople because they beat up on me, right? They'll plug in proxy server information so they can basically get around all of your website filtering or whatever that you have. And so a lot of times, right, they'll futz with all these configurations and it all goes to hell, and then you're sitting there trying to figure out why. Go in, reset the IP address configurations on the computer, and you should be good to go. Again, do be careful with putting multiple DHCP servers on your LAN. Essentially, think about the LAN as a switch. Again, there's something called VLANs. Anyways, don't worry about VLANs. Anything connected to the switch, right? Anything connected to the switch, more or less, make sure there's only one DHCP server. If you're going to have more than one DHCP server, know what the hell you're doing and why. Because if you have multiple DHCP servers connected to the same LAN and they're not configured properly how they should be, you can run into lots of problems. You can basically have two entirely different IP address schemes being sent out to the different clients. Again, like I say, with Microsoft DHCP servers back in the day, if they recognize a different DHCP server on the network, they would just turn themselves off for some reason, which was its own idiocy. You can run into a lot of problems. So again, if you're dealing with the Microsoft world, right? Microsoft, really believes in backup services and backup servers. So in that world, you can have your primary DHCP server and a secondary DHCP server. So if one fails, the network auto fails over the second one. But that's a configuration within the Microsoft world. You're more or less not going to be dealing with that type of thing. Again, you've got your scope. The big thing to remember with your scope is to think about creating a static IP address scheme at the beginning of your subnet. So again, if you have 192.168.1.x, I would say reserve .1 through .20. Just allow yourself 20 IP addresses that you can statically configure for servers, networking equipment, printers, that type of thing, and then release the rest of the scope to the DHCP server. Again, 192.168.1.21 all the way up to 192.168.1.254. And then you can have that entire scope. Do not put basically static IP addresses or addresses that are being used statically within the scope, or the DHCP server may actually provide those IP addresses to other computers. You get two IP addresses on the network, everything kind of goes to hell. Again, we'd look at reserved addresses. Generally, reserved addresses when you're dealing with DHCP is more or less kind of like a notebook. It tells an administrator what addresses are reserved for what. Okay, 192.168.1.21 is reserved for the router. 192.168.1.10 is reserved for the Active Directory server. 192.168.1.21 or whatever is reserved for the Exchange server. But it's more like a notebook. It's more like informational purposes. And then you as the administrator, you look to those reserved addresses, and then you go audit your infrastructure and make sure those computers are actually there, right? Because again, you think about old infrastructure, you may have addresses that got reserved 10 years ago. So let's say back in the day, you had a cluster of servers because servers weren't very powerful back then. So you had 5 servers to provide one service. You had a refresh cycle. Servers became more powerful, so now you have one server in order to provide the same service. You may still have reserved in the system those 5 different IP addresses simply because nobody went in and just took them out of the system, right? So that's one thing to think about. Then you get down to the DHCP, the lease length. So the lease is essentially how long an IP address is given to the host computers. Again, if you're dealing with a pretty static environment, I would say put that at a week. Every time a client has to talk to a server, quirky crap might happen. The less they talk, the better in general. And so if they don't have to communicate very often, that's good. Again, in a cafe that offers Wi-Fi access, though, you may need to have a very short lease length. Maybe like say only an hour. You may have some quirky problems, but hey, you sell coffee, you're not really selling an internet service, so you just ignore the problem. Again, that's what a lot of these companies do nowadays. Hotels, internet cafes, that type of thing. It's not that they don't have problems with their network; they just don't care. They can do that. They can do that. We sell coffee and bagels. The Wi-Fi is an additional thing. Anyway, so with them, they may want to cut that lease length down to an hour just to make sure that they have enough IP addresses that the DHCP server gets back the IP addresses that it's handed out so it can give to more users. Do remember with this too is that server services work together. They work in tandem many times. So DNS and DHCP generally should be on the same box. If they're not on the same box, they should be communicating with each other, however you do that particular configuration, right? Because again, not only do you want the client to get that IP address, but you also want DNS to register whatever their host name is. So if a different computer on the network needs to be able to access that host, it can just resolve the host name to the IP address and go from there. If your DHCP and DNS are in two entirely different boxes and you have not somehow configured them to communicate, you can run into some really weird DNS resolution problems, so be careful with that. The same is true again when you're dealing with the Microsoft world. Again, the Microsoft world, once you have decided on the Microsoft stack, here's the thing. There is a huge argument on whether or not you should decide to go with the Microsoft stack. That's its own argument. That is an argument. Here's what I'm going to tell you. Once you or your company has decided to use the Microsoft stack, don't be a smarty pants. Just use the damn Microsoft stack. Again, when you start talking about DHCP, DNS, Active Directory, routing and remote access services, when you have so much stuff that is so tightly interwoven within the Microsoft world, and so when you decide to start using a pie hole for your DNS services, for your 100-person company that uses a Microsoft Active Directory, it's not going to go well for you. I'm just going to tell you, it's not going to go well. So in the Microsoft world, again, once you've decided to use Microsoft or your CEO has decided to use Microsoft, you just stick with that world. So I hope all that makes sense. I hope that makes sense. This is one of those classes. It's ended up being a lot longer than I thought it was going to be. It was like, hey, I'm just going to sit there for 20 minutes and explain DHCP. And then it's like, oh, well, yeah. Took a little bit longer than 20 minutes. But hopefully now you understand more about dynamic host configuration protocol. Again, it's an incredibly valuable thing. Honestly, it's relatively easy. If you don't fat finger and you check and you verify and you make sure what you're doing before you hit the apply button, it's a very, very, very simple service that makes everybody's life a lot easier. The problem that you're going to run into, though, is it's such a simple service. People decide to do really stupid things, and then your life becomes miserable. Again, that's where I talk about the OSI model, the 7 layers of the OSI model, and I talk about how using those layers are useful for troubleshooting where a problem is. Again, this is one of those things where you sit there and your salesperson is having a problem connecting with the database server, and if you can go through and you can start getting really good at the troubleshooting routines, this is just one of those things where it's like, okay, I see the green light is blinking, or the Wi-Fi thing is connected, so I know they're connected to the network. I know everybody else in the local area network, everything is communicating fine, so I know the server is up and running. I have a salesperson in front of me. So the first thing that I'm going to do after I've done all of that is simply go into network configurations and clear out all the crap they threw in there, and then see if the problem is solved, right? That's why things like the OSI model are important. Again, it's that whole troubleshooting process, trying to understand where you think the problem may be, and also understanding why you might be having that type of problem. So anyways, There you go. Hope that made sense. Hope it made sense. As always, I enjoyed teaching this class. Look forward to seeing the next one.